जैसे बेटे आप लोग क्लास में बैठे होते हो, द टीचर इज टीचिंग यू, सारे बच्चे तो अटेंटिव नहीं होते, तो सारे बच्चे तो होगी मोलर कंसंट्रेशन, लेकिन उनमें से जितने अटेंटिव हैं वही एक्टिविटी है। उसी प्रकार हम यहां पर एक्टिविटी यूज करेंगे। प्रैक्टिकल पर्पस के लिए एक्टिविटी एंड मोलरिटी हैज नो डिफरेंस। pH of neutral solution is 7 at 298 Kelvin, but as temperature is increased, the value of K increases, so pH decreases. The pH of 0.01 normal HCl and 0.005 molar H2SO4 will be, whenever you are solving the questions of pH, please take either normality of the acids or concentration of hydronium ions only. Don't take molarity of the acid. If molarity of the acid is given to you, then concentration of hydronium ions is equal to molarity of the acid into basicity. So for H2SO4 it will be 0.005 into 2, which is 0.01. So both H2SO4 and HCl are 0.01 normal. Hence in both the cases the pH will be 2. So the answer will be first. Another question. 50 milliliter 0.001 molar HCl is mixed with 49.9 milliliter 0.001 molar NaOH. Then pH of the resulting solution will be, whenever you are mixing an acid and a base. Dear students, first of all find out the number of millimoles of H ions, which is volume in milliliter into molarity, which comes out to be 50 into 0.001 means 0.05. In the same way, number of millimoles of OH ions, which is again volume in milliliter into molarity into basicity, which is equal to 49.9 into 0.001 means 0.0499. Now in this case, when you subtract the two, you will find out that it comes out to be 100. So OH H ions will be in excess. Now number of excess of H ions divided by total volume of the solution, which is nearly 100, that will give you the concentration of H ions, and you can find the molarity of the solution, which will come out to be 3.699. If two acids are mixed, please see to it the pH is decided with respect to the strong acid. Weak acid has no contribution towards pH because its dissociation will be further suppressed. If you are mixing two acids in equal volumes, supposing you are mixing, in the next question, you are mixing solutions of pH 2 and pH 3 in equal volume. Dear students, in such cases the answer will be 0.3 more than the one which has lesser pH. Supposing he says you are mixing solution having pH 2 and 4, 2 and 5, 2 and 6, 2 and 7. In all these cases the answer will be nearly 2.3. But if you are mixing 2 and 12, 1 and 13, 0 and 14, or 3 and 11, that is to say the total comes out to be 14, then the pH of the resulting solution will be 7 because it is, one is acid, other is base, and the solution will be neutralized. Now another question, pH of water at 298 Kelvin is 7. If it is heated to 60 degree, then its pH will be. Dear students, we know that with the increase of temperature, the value of K increases because dissociation of water is endothermic. So formerly the K was 10 to the power minus 14. Let us say now the value of K is 10 to the power minus 13 and pH is equal to half pKw. So the value will come out to be 6.5. You just see the choices, less than 6, less than 7, whatever is the value, that is the answer. So the answer will be 6.8. Now whether the solution will be acidic, basic or neutral, dear students, it is water, and water will remain water even if you heat it. So the solution will remain neutral. Now our reference point will be less than 6.8 is acidic, more than 6.8 is basic, and 6.8 is neutral. Another question, what is the pH of a solution obtained by adding 0.1 mole HCl to 1 liter of 0.1 molar NaNO2? NaNO2 is a salt. HCl, when you add NaNO2 and HCl, the reaction that takes place is NaNO2 plus HCl giving you HNO2 plus NaCl. Now HNO2 is a weak acid whose dissociation constant has been given to you. So you can say now the HNO2 will be 0.1 molar. So the concentration of hydronium ion in the case of weak acid is Ka into C under the root. So 4 into 10 to the power minus 5 into 0.1 under the root. So it will be equal to 4 into 10 to the power minus 6 under the root. So it will be 2 into 10 to the power minus 3. So the answer will be 2.69. Common ion effect. Suppression in the dissociation of a weak electrolyte by adding an ion common to it is known as common ion effect. Dear students, common ion effect is nothing but the application of Le Chatelier principle. We have seen in Le Chatelier principle that if the concentration of the product is increased, then